evens out. You put ice cubes in there, put ice cube up too high, it's going to sink down to where the amount, where the mass of the ice, total mass of the ice, equals the mass of the water displaced by the ice. And the same with a rock. If you put a big rock on the surface, even a little rock, over time, the rock sinks in to where the total mass of the rock equals the average density, average mass of the material it's displacing. So in order for you to have a mountain up here, you got to have a root down here to keep it up. Just like in order to get ice above water, you've got to have a bunch of ice beneath the water to hold the ice up. It's in isostatic equilibrium, if it's in isostatic equilibrium, if it's happy, as my roommate from New York City used to say, anything which was where it was supposed to be, where he liked it, was called happy. So I'll use that anthropomorphism. It sort of says it all. The mountain is happy if, in fact, it's got a root to hold up the stuff that's up above. See, mountains have to have roots, or else they're going to be sinking. In this mountain chain does not have any roots. Okay, it's got almost a flat bottom surface here, a little bit below the surface that you can see. Actually, there's a pediment off to the side, but just about that dark to light line there is the base of this whole thing. It's sitting there off of its base. The chemistry of the rock matches the chemistry of a flat-topped Pluton about 60 miles away. It's the same size, same chemistry. It's shaved off at about ground level, and this puppy is 60 miles away. What's going on here? We know when the earthquake activity, or whatever it is, occurred, because, of course, it's younger than the Pluton that it intrudes. The Pluton's after the flood, so dates from after the flood. So this thing is broken off after the flood. So first of all, you got to break a mountain. Then you got to move the top of the mountain 60 miles away. I would suggest that's not easy to do. Try not to be too profound here, but you got to have a really big hit to break it in the first place, and you got to have a continuous series of very, very big hits to vibrate this thing across. And of course, once it stops, you got to even harder to get it going again. You know, the vibrational friction, the coefficient of friction when it's moving is less than the coefficient of friction when it's sitting still. And so the easiest way is to break it off with a humongous earthquake and then have a whole series of really strong earthquakes, keep it moving until it moves 60 miles away. But of course, this isn't the only mountain like this. In fact, this is in San Bernardino County, but also in San Diego County. As near as we can tell, every single mountain in San Diego County has no base. It is off its roots. In fact, on either side of the San Andreas Fault, for 200 miles in every direction, every mountain is broken off of its top and vibrated from 80 miles to 30 miles away. The Catalina Islands are mountains vibrated out into the ocean. They don't belong there, okay? This is mind-boggling. There was a time after the flood when the earthquakes were so intense as to be able to break mountains off and vibrate them dozens of miles across the surface away from the fault. Though I would suggest those are superquakes. And the quakes we are having in the present are nothing compared to these things, okay? This is moving mountains. I mentioned this in the Arphaxadian epoch. I mean, talk about a wild time. Ooh, there goes my mountain! Yikes! I don't know how to say this in any way, but whoa. And the more we learn about it, the more incredible it becomes. And of course, even now we have earthquakes occurring, mountains are moving. We've got the Tetons are moving with respect to Jackson Hole. I mean, you could go either way, whether Jackson Hole is actually the one moving or the mountains. It's 1.5 inches per year. The mountains are rising relative to the valley. This makes sense if the mountains were put in place out of isostatic equilibrium only thousands of years ago. They're still going back into isostatic equilibrium. It doesn't make sense if these mountains truly are 60 million years old, which is the traditional idea. Because as near as we can tell from the nature of the Earth, you realize that ice cubes don't take long to go to isostatic equilibrium. But put an ice cube into honey, and it takes longer, right? Because of the density of honey doesn't allow it to move as quickly. And so the viscosity of the Earth itself is pretty high. It takes a long time for a rock to move into isostatic equilibrium. We estimate about 25,000 years. I suspect creationist dating would make that shorter because those estimates are based on some evolutionary or some uniformitarian assumptions. But we're talking about probably thousands of years for something to go, we'll say 10,000 years for something to come to isostatic equilibrium. Flood's only 4,500 years ago. If these mountains were formed during the flood, it makes sense that some of the valleys are too low, some of the mountains are too high, and we're readjusting even to the present. It does not make sense if they're 60 million years old. It's even worse back in the Appalachians, where I lived for 17 years. The geologically most active region in the United States, west of the Rockies, is in fact Cleveland, Tennessee. Bet you've never heard of Cleveland, Tennessee. Cleveland, Tennessee, the Olympics a number of years ago had whitewater rafting on the Ocoee, which is right there in Cleveland. That's one thing. It's right in the Appalachians, in those humongous mountains, all less than a mile high, that make up the Appalachian Mountains on the east coast of the United States. Those mountains are supposed to be 300 million years old. They should not be moving. The only movement would be erosion off the surface that then allows for then a little bit of rebound upward as the roots bring it up in response to the erosion. But that ain't going to be much. But Cleveland, Tennessee feels 4 earthquakes a day. Those mountains are currently moving. And it makes no sense in the conventional wisdom, but it makes sense in terms of a flood. So we have moving mountains even today, but nowhere like the early Arphaxadian epoch. Climate is also wild. Of course, we're suggesting that